We did discuss OH group, then acidic group. Under the acidic group, we did discuss mostly the carboxylic acid, the sulfonic acid, and phosphonic acid. And among these, I did talk to you, whenever the functional group alcohol is added, it is more water soluble and less lipid soluble, and it affects upon ADME and T, more effect. On the other hand, when acidic group is therein, this acidic group is very soluble in water. Similarly is the effect of sulfonic acid. Sulfonic acid is also important for excretion of the drug. This you will study while we will be dealing with the metabolism. How does glucuronic acid is formed, and this sulfonic acid is responsible for glucuronization, and easily the drug would be eliminated. You will be discussing these while you will be sharing metabolism, a particular syllabus aspect. Then phosphonic acid is also important for elimination of the drug. So acidic group is important in a way water solubility is increased. Moreover, in the acidic groups, all those drugs which are not easily be solubilized, in them acid group has been added, and sodium salts or any other salts are formed, and drug can be easily mobilized into the body and easily be eliminated from the body. These are the pretty good aspect of the acidic group. And then we discuss the amino group. Under the amino group, this N is attached to the compound. It becomes very reactive and very toxic, and we don't need toxic, so we have to make certain other analogues which are very reactive but least toxic. That's why this amino group is important and nitro group is important, and in that respect the basic group usually found in analogues are amines, amides, and guanidines. All basic groups can form salt in the biological active medium. Now this is the important issue, salt formation, which is also exhibited by acidic group as well. Consequently, incorporation of all these basic groups into the structure of a lead will produce analogs that have a lower lipid solubility but increased water solubility. This means that more basic an analog, the more likely it will be formed salt, and the less likely it will be transported through a lipid membrane. Primary amines are usually more indiscriminately active and toxic than secondary amines, and the latter are followed by tertiary amines, secondary and tertiary amine with flexible substituents. This sp3 orbital with the unpaired electron of the nitrogen, which are placed here and upon the nitrogen, may be a compressed steric crowding, and sp3 hybridization would let it to be mask these two electrons which are present upon the nitrogen. Now the effect on aromatic ring. The introduction of an amino group to an aromatic ring usually results in increased toxicity of a compound. Benzene is less toxic, but after introducing the amine group, the resulting compound is aniline, with shows more toxicity, blood poisoning, as compared to its parent compound. So this is benzene. Benzene is non-reactive. When it is converted into aniline, it is reactive, but it is toxic. Blood poison is also there. It has got another activity. Convulsant activity is also there, and paralytic activity is also there. And when we add into it CH3 group, the convulsant property has been abolished, goes off, dies off, decays off, whereas paralytic activity is sustained therein. The alkyl group is added to the aniline. The convulsant effect is lost, but paralytic effect is retained. Reduction of the basicity of the primarily and secondary amine by acylation decreases the overall activity, and so does the introduction of electron withdrawing group, especially carboxylic acid, sulfonic acid, and on into their molecule. The resulting bipolar ion exhibited depressed biological activity. Now the next group is the effect of Nitro group. NO2, wherever N is there is a lone pair upon it. That lone pair is very toxic and one should avoid from it. It usually causes the cancer in the body. As a general rule, the introduction of Nitro group into the lead molecule increases the toxicity as well as reactivity. But we need in between therein more effective, least toxic. We have to make many analogs and they have been administered into the body and in vivo they have been checked, and then we could be able to know which one is the correct and which can be administered into the body. Then a series of compound has been formed. That's why I used to say every year 10,000 compounds are being synthetically synthesized by synthetic chemists, and out of these only 1, 2, 3 or 4 could be able to attain the status of a drug. Now the effect on aromatic ring. This is a benzene. You have performed nitration and it will be converted into nitrobenzene. By introducing nitro group in benzene molecule result in the form of a nitrobenzene, which is more toxic than benzene. However, the presence of others group modify the activity of the compound. For example, by introducing methyl group or methylation, we get para-nitrotoluene, which is less toxic than nitrobenzene. This is nitrobenzene. This is toxic and this is less toxic when you introduce into it methyl group. Now, effect of aliphatic compounds. Now you can see this is OH group, OH group, OH group. This would be glycerine and glycerol. Nitration has been taken place. This reaction occurs in the presence of sulfuric acid and nitric acid. And water molecule released from here, water molecule released from here, water molecule released from here, and a nitro group has been introduced into it, and it has been converted into trinitroglycerine. It is a very effective compound. Gives trinitroglycerine, which is extremely useful compound in patient suffering in vasoconstriction and angina pectoris problem. You have seen nitroglycerine is given in the angina pectoris problem. Now the effect on chloramphenicol. And if you look at the structure of chloramphenicol, this is the nitro group. 90% activity as antibacterial is due to this nitro group. Otherwise, this is not antibacterial compound. When you incorporate, introduce into it this nitro group, it will be able to act as an antibacterial compound. Thank you very much. This was my previous lecture. Now, next lecture which I was going to deliver to you, effect of aldehyde and ketones. You are well aware of it. Now, you can see aldehyde are usually more reactive than ketones and exhibit a more intense biological activity. For example, formaldehyde is a potent antiseptic, kills cells and hardening tissue by precipitation and coagulation of protein. Ketones are pharmacologically more likely corresponding secondary alcohols, but both aldehyde and keto group occurs in such a wide variety of compounds that generalize are not possible. Now I can give you the example. In this case, aldehyde is more reactive. If you could see the structure of vitamin B6, pyridoxine, this is available in 3 forms, that is alcohol form, keto form and nitro form. You can see the aldehydic form of it is more active than all other form, an alcoholic form and nitro form. And the next group is the halogen. So this is the halogen which make the compound more lipid soluble as compared to all others. And the halogen has got the property in this respect to cross the membrane. Now the effect of halogen atom, in halogens are included X, chloride, bromide, iodide and fluoride. 7th group is included in it. The incorporation of halogen atoms into the lead results in analogues that are more lipophilic not lipophobic. This is a lipophilic. This is the only element which is responsible to increase the lipid solubility, and drug can cross easily from the membrane as compared to all other which we have already did discuss, that is alcoholic, acidic, carboxylic acid, sulfonic, phosphonic, nitro, amino, and so on and so forth, aldehyde and ketonic. It is the only halogen atom which is responsible to increase the lipid solubility as compared to all others. So less water soluble is, consequently halogen atoms are used to improve the penetration of lipid membrane. However, there is unreversible in the lipid tissue. The chemical reactivity of halogen atom depend both on their point of attachment to the lead and the nature of the halogen. I can give you example in this case. If you could see diuretics. In the diuretics, chloro position at different places increase, decrease and modulate the diuretic activity. Now the next is aromatic halogen group are far less reactive than aliphatic halogen group, which can exhibit considerable chemical reactivity. The strongest and least reactive of these aliphatic CX halogen is carbon bond in the CF bond. It is usually less chemically reactive than aliphatic hydrocarbon. The other aliphatic carbon halogen like this, chlorine, bromine, iodine and fluorine bond are weaker. So more reactive, their reactivity increase as on moves to the periodic table. They are normally more chemically reactive than aliphatic hydrocarbon. Now here is the example of that, already diuretic, and there is another example in that respect. Changes in potency caused by the introduction of a halogen or halogen containing group will, as with substitution by other substituent, depend on the position of the substituent. Antihypertensive chlorine with ortho chloro substituent is more potent than its para meta dichloroanalol. And here is the example. You can see this is ortho. You can see ortho chloro chlorine, and here is arthro meta para. So para meta chloro is less biologically active than ortho chloro form of chlorine. So this is a pretty good example. Similarly, I have given you the example of diuretic aspect of it. It is believed that the bulky ortho-chloro group impose a conformational resistance to the structure of the chlorine that probably occur for its increased activity, and the reason has been given here in that respect. The next is the effect of unsaturation linkage, that is double bond and triple bond. What double bond and triple bond do? The effect of unsaturated linkage. Wherever there will be double bond will be more reactive. This has got pi electron upon it, and those pi electron can act as a nucleophile. And here is that one. You can see this is double bond. You see like this. These are pi electrons, and these pi electrons act as a nucleophile and easily attack the electrophile. That is why the double bond is more reactive than single bond. And similarly, the two is of triple bond, and you can see in the triple bond you can see like this, there will be two pi bonds, more electrons. So in that way you can see these are more effective in this way. The unsaturation of an organic compound is defined by the presence of double bond and triple bond in general, unsaturated compounds are reactive than saturated compound, and same is the true of the pharmacological activity. So double bond is more reactive. This has got pi electron, act as a nucleophile and attack easily upon electrophile, and in the body attachment can be take place in this way. So same is the true of pharmacological activity. If there would be nucleophile, it will attack upon electrophile and bonded here and in this way, and a quite good linkage between the functional group and the receptor would have been taken place. The same is cause of pharmacological effect. The unsaturated compounds have been found to be more toxic than their corresponding saturated compound. This is true. More effective, more toxic. But we have to come to the point where it is more effective and least toxic, and we have to make many analogs, and out of that quite a few would be able to chosen, and it can act as a drug. It's very difficult task. That's why you used to say every year 10,000 compounds have been synthesized by synthetic chemists, and out of that 1, 2 or 3 or 4 even could be able to attain the status of a drug. This is the reason behind it. Propyl alcohol has mild narcotic property but is non-poisonous, while its unsaturation analog, here is double bond, is a more reactive but more poisonous is this one. The removal of double bond increase the degree of flexibility of the molecule. This is the double bond. Look at double bond won't let this molecule, if this is the double bond, molecule cannot rotate in this way. But it is a single bond, it can rotate like this. So this double bond give rigidity to the molecule, non-flexible. This is flexible. It keep on rotating like this. But it cannot. When it start moving here, this would let it to be resist. Moving that way, this will also let it to be resist. Don't move hither, remain here. But it can move in a round way. That's why this compound is flexible. This is not flexible in that respect. I think so you could be able to understand this point. This is a crucial point to be understood here. And the removal of double bond increases the degree of flexibility of the molecule, which makes the easier for analog to fit into active site receptor sites, but taking up a more suitable conformation. However, an increase in this increase the toxicity as well. Thank you very much, my dear students, my dear brothers and sisters, sons and daughters. This was all about this. Today, according to your will and wish, again I have to come to the YouTube. Yesterday it was very difficult task for me. Room was occupied, that's why I was not able to hear and could get the facility for YouTube. And now I have delivered the lecture on YouTube. If you feel like any problem, do talk to me, and I am going to give you once again my mobile number 0300416375. Thank you very much, my son and daughter. Allah Hafiz, fi amanullah, wallahu khairan hafiz.